Hi everybody, welcome to Unit 1, video number 3. If you do not have your Show Me What You Can Do notes out, please pause the video and go get them. All right, so let's take a look at topic number 7. I can solve absolute value equations. Solve, leave the answer as a lowest term mixed number. Okay, so remember, when you're doing absolute value equations, you're actually setting up two equations because remember, absolute value is the distance away from 0 on the number line. And so like -2 and +2 are both two spaces away from 0 on the number line. So we have to account for that. So when you do this, what you want to do is you want to set up your two equations. You do not change anything in the absolute value. You leave it alone. So you have -2x minus 10 is equal to 2. So that's our first equation. Our second equation, again, do not change anything in the absolute value. So you're going to say -2x minus 10 equals, this is where you change something, equals a -2. Because again, you're counting for both sides of the number line. So now that we have our equations, we're going to go ahead and solve. So I'm going to solve the left-hand side first. So here, I'm going to add 10 to both sides. So I get -2x equals 12. I'm going to divide each side by a -2. So I get x equals -6. Then I'm going to go ahead and solve my other equation. So I'm going to add 10 to both sides. So I'm going to get -2x equals 8. I'm going to divide each side by -2. And I'm going to get x equals -4. So now my solutions for my inequality here are x equals -6 and x equals -4. All right, I want you to pause the video and I want you to try number 24. And remember, you do not change anything inside of the absolute value sign. Okay, so let's see how you did. So remember, the first equation, you can leave it the same. 3x plus 10 equals 20. The second equation, do not change anything from the absolute value. Just rewrite it, 3x plus 10, but you do change the sign of this number. So now it's a -20. All right, so when I solved here, I got x equals 10 over 3, but the question asked for lowest term mixed number. So I turned this into x equals 3 1/3. On the right hand, on the other equation, I got x equals -10. Okay, so let's take a look here at topic number 8. I can simplify radicals. So remember, when you simplify radicals, you're looking for the biggest perfect square factor that you can take out. Like, for example, this one. You could factor it down and say, okay, I'm going to divide by 2. I know 2 goes into 80, but then you're left with 2 and 40. And so you'd have to divide 40 again, and you'd have to keep going until you had it all the way in simplest form. The easier way to do it is to look for the biggest perfect square factor. So the biggest perfect square factor of 80, in this case, would be 16 times 5. 16 is a perfect square, so that's why I wanted the perfect square factor. All right, so when I factor this out, the square root of 16 gives me 4. I can't take the square root of 5, so I get 4 rad 5. All right, pause the video and you try number 26. And again, you want to look for the biggest perfect square factor. You can use 2, but you'd have to do a lot. You'd have to do like a factor tree and keep going. So try to see if you can figure out what the biggest perfect square factor of 486 is. Okay, pause the video. Okay, were you able to get it? The biggest perfect square factor was 81. 81 times 6 gave me 46. 81 is a perfect square. So the square root of 1 is 9. I can't take the square root of 6, so I got 9 rad 6. All right, let's take a look at number 27. So the only difference with these types of problems is now you have to remember there's an implied multiplication sign between the 8 and the radical. So, but again, you want to look for the biggest perfect square factor. So we're going to say 8. So try to think, what is the biggest perfect square factor of 216? So did you get it? 36 and 6, so 36 times 6 would give me 216. And so when I take the square root of 36, I'm going to take it out of radical, but remember, there's that implied multiplication sign. So I get 8 times 6. I can't take the square root of this 6. So I leave it underneath the radical, and then I just need to simplify these. So 8 times 6 is going to give me 48, and I can't do anything with the rad 6. So my final answer is 48 rad 6. All right, I want you to try number 28. Again, try to see if you can find the biggest perfect square factor of 245, and then simplify. Okay, so how'd you do? 49 was our biggest perfect square factor. So remember, there's an implied multiplication sign. So negative 6 times 7, rad 5, gives us negative 42 rad 5. All right, let's look at topic number 9. Remember, all of this is a review from Algebra 1. So I know it's a lot, but hopefully you're starting to remember what you did in Algebra 1. Okay, factor completely. So remember, when we're factoring here, we're looking for the factors of negative 72 that add to a negative 1 in the middle. So you want to put your 2 parentheses. We already know the factors of x squared are x, and we're saying what would multiply to a negative 72 but add to a negative 1. So we have a negative 9 and a positive 8. Because remember, if you were to distribute this back, you'd get x times x is x squared. Here you get an 8x. On the inside term, you get a negative 9x. So 8 minus 9x would give you a 1x. And negative 9 times 8 gives you a negative 72. All right, with this one, again, it's very similar, except the first rule of factoring is you should always look for a GCF, or a greatest common factor. And in this case, there is a greatest common factor. So I want to factor that out first. It is a 2. So I'm going to factor or divide everything by 2. So that's going to leave me with this. X squared minus 3x minus 28. And then I have to say, what are the factors of negative 28 that add to a negative 3x? So think what multiplies to a negative 28 but adds to a negative 3. So we have negative 7 and a positive 4. So this would be my factored form. We factor out the GCF, then we factor the inside trinomial. All right, so topic 10. I can solve quadratic equations by factoring and finding the roots. So now we're actually solving for them. See how they're set equal to 0, which means now we want an answer for x. But we started off the same way. We say, okay, we have our 2 parentheses. We know the factors of x squared are x and x. And we're saying, what are the factors of 18 that add to 11? Well, what's going to multiply to a positive 18 and add to a positive 11? Well, that would be a positive 9 and a positive 2. Okay, but in this case, now that we're solving for x, we have to figure out what both answers are. So we have to set both of these equal to x. X plus 9, or sorry, equal to 0. X plus 9 equals 0, and x plus 2 equals 0. So let's go ahead and solve both of them. Here, I'm going to subtract 9 from both sides. So I get x equals negative 9. So when it says find the roots, this is the root. This is where your parabola would cross your x-axis, okay? So x equals negative 9. Here I'm going to subtract 2 from both sides. So I get x equals negative 2. So my 2 solutions, or my roots, would be x equals negative 9 and x equals negative 2. All right, 32, again, is very similar, except the only difference here is we always start with our first rule of factoring, which means we have to factor out the GCF first. So there is a GCF in this case, which is 3. So I'm going to divide everything by 3, or I'm going to factor it out. So this is going to give me x squared plus 2x minus 80 equals 0. So then I'm going to bring down the 3. I'm going to bring down my 2 parentheses equals 0. I know there's an x and an x. And I'm saying, what are the factors of negative 80 that add to 2? So it multiplies to a negative 80 and it adds to 2. So I'm going to get a positive 10 and a negative 8. Those would add to a positive 2 and multiply to a negative 80. All right, and again, I'm solving for x, but only these 2 have x, so I don't need to worry about the 3. I'm going to set x plus 10 equal to 0, and I'm going to set x minus 8 equal to 0, and then I'm going to go ahead and solve. So here I'm going to subtract 10 from both sides, so I get x equals negative 10. Here I'm going to add 8 to both sides, So I get x equals 8. So my two solutions, or my roots, are -10 and 8. And again, remember, these are the 2 points where your parabola would cross your x-axis. All right, so let's go ahead and take a look at topic number 9. I can graph linear equations. So in order to graph linear equations, you have to first know the equation of the line. And remember, equation of a line, we want in slope-intercept form. And slope-intercept form is our y equals mx plus b. So y equals mx plus b. Plus b, where m is the slope, or you can think of your rise over run, and this is the y-intercept. It's the point at where your line crosses the y-axis. So if you have a ruler, take the ruler out and you can use it as a straight edge. Okay, so let's go ahead and put this into slope-intercept form. We want the y by itself, which means we're going to have to subtract 6x from both sides. So we have 2y equals -6x plus 14. Then I need to divide each side by 2. So I get y equals -3x plus 7. So now that I have it in slope-intercept form, I can go ahead and graph. So that means my y-intercept is 7. So I'm going to go to 7 on the y-axis. And the slope is -3. Remember, there's an implied 1 in the denominator, -3 over 1, which means I'm going to go down 3 units and over 1. So I'm going to go down 3 units and over 1. I'm going to do it a couple times. Down 3 units and over 1. And then you can go more if you want. Down 3 units over 1. And if you have a straight edge, I unfortunately don't have a straight edge right now, so I'm going to, best I can, try to connect the dots. Hopefully yours is a lot straighter line than mine is. Okay, I want you to pause the video and you try number 34. Okay, so how did you do? Our line should be y equals 2 over 3x minus 3. So our y-intercept means we started at -3 on the y-axis, and our slope was 2 over 3, so we went up 2 over 3, up 2 over 3, up 2 over 3. All right, so let's go ahead and look at topic number 12 here. I can apply the rules of special right triangles. So hopefully you remember the rules of your special right triangles. You probably did this in Algebra 2 and in geometry. And these are the rules if you don't remember. Oops. For a 90-degree triangle with a 45, 45, 90, opposite of 45 was A, so this is A, and opposite of 90 was A rad 2. Okay, for a 30, 60, 90, so here's 60, here's 30. Opposite of 30 is A. Opposite of 60 is A rad 3. And opposite of 90 is 2A. All right, so let's go ahead and apply those rules. So we're solving for both x and y. So in this case, opposite of 45 here is y, and opposite of 90 here is x. So I already know in a 45, 45, 90 that if this side is 2, that means this side is 2. And opposite of 90 is A rad 2. So x is going to be equal to A rad 2, which in this case is 2 rad 2. So if you want, you can write A equals 2 over here. And y is going to equal 2. All right, so let's go ahead and take a look at number 36. So again, we're applying our rules. We want to know what y is. And in this case, y is the opposite of 30. And x is the opposite of 90. So let's start with what we're given with 60. Well, opposite of 60 is A rad 3. And in this case, it's 5 rad 3. So we have to say A rad 3 equals 5 rad 3. So in order to get A by itself, we would divide by rad 3. These would cancel, which means A equals 5. So now that I know A equals 5, opposite of 30, in this case y, would equal 5. And opposite of 90, in this case, which is x, would be 2a. So x is equal to 10, because 2 times 5 would give us 10. All right. It says, and there was an error on this one on your page. If you want to correct it, find the 3 trig functions of theta, not 6. So go ahead and cross that out on your paper if it says 6. All right, I can define and find the trigonometric functions of acute angles. Okay, so here we go. We're looking for this angle theta here. And so sine. We know that sine is opposites over a hypotenuse. And in this case, I'm given both of those things. The opposite is 16 and the hypotenuse is 20. So 16 over 20, which you can reduce to 4/5. So the sine of theta is 4/5. All right, now for this one, cosine theta would be adjacent over hypotenuse, which means you need to know what this side is. And right now you don't know it, but you can solve for it. So try to think, how do you solve for the missing side of a right triangle given 2 other sides? You guessed it, Pythagorean theorem. So you're going to say a squared plus 16 squared equals, 20 squared. That's a 20 squared. Let me try to erase that. 20 squared. Okay, so we want to go ahead and do the computation. So a squared plus 256 equals 400. You're going to subtract 256 from both sides. You're going to get a squared equals 144. But we want a, not a squared, so a equals 12. So that means that my side over here is 12, or my adjacent. So for cosine, I have adjacent over a hypotenuse, which is going to give me 12 over 20, which I can simplify here if I divide them both by 4 into 3/5. All right, so tangent, opposite over adjacent. So opposite of theta would be 16, and adjacent would be 12. So we have 16 over 12, which again, I can reduce if you divide by 4. So you're going to get 4/3, and you can leave it as 4/3. Do not change it into 1 1/3. Leave it as 4/3. All right, so that was a review of some of our trig. 19, I can solve and graph inequalities and write their solutions in interval notation. All right, so you'll probably know how to solve these. You probably know how to graph them. The part that you may not be familiar with is the interval notation. And interval notation is just another way of writing our solution. So first let's solve it, and then I'll show you the interval notation. All right, so I want to get solve for x. So first what I'm going to do here is I'm going to multiply each side by 4. So I'm going to get, that's going to cancel this out. So I get x plus 2 is less than 1/2 times 4, which is going to give me 2. So I'm going to subtract 2 from both sides. So I get x is less than 0. All right, so when I go to draw this out, it would look like this. Remember, I have my number line. Here's 0 in the middle. I'll say, oops, +3. Here's -3. So when you graph this, it's saying x is less than 0, which means you would put an open circle on 0 and say everything to the left of 0 would be a solution. Okay, so now let's write this graph or this solution in interval notation. So here's what you need to know about interval notation. Instead of using an open circle, we use a bracket. Open circle means it's not included in as an answer. So like you can't say 0 is less than 0. It's not true. 0 is equal to 0. So you have to choose numbers that are lower, like -1 is less than 0. So open circle, circle meant not included. This is not included. So you would use a parentheses, okay? And just like you have open circles, you also have closed circles. Closed circles when you did the number line. And when you closed circles, it meant it was shaded or included. You would use a bracket, okay? So when you write this, you always look from the left to the right, least to greatest. This is going to the left forever and ever and ever. And the direction that's the left forever and ever and ever is negative infinity. And since negative infinity cannot be included or closed or encaptured, you have to always use a parentheses with negative infinity. So our I looks this way. So we'd say all those solutions from negative infinity all the way till we get to here, to our open circle at 0. So at 0. But 0 wasn't included as a solution, so we put another parentheses. So this is the interval, parentheses negative infinity to 0, parentheses. So that's the same thing as saying what this drawing has here. As again, you're reading left to right, you're saying all the solutions from negative infinity until 0, not including 0. That's why you put a parentheses. So let's go ahead and try this next one here. So again, I'm going to start by multiplying 2 to both sides. So I get negative t is greater than or equal to 3. But I need t, not negative t. So I'm going to divide by a negative 1. Remember, when you divide by a negative, it's going to flip your inequality sign. So I get t is less than or equal to negative 3. Okay, so kind of like the one I just did, I have negative 3, 0, positive 3 here. So I'm going to do this time, since it's less than or equal to, it means it's a closed circle and everything to the left of negative 3. So this time to write the interval, again, your I starts left to right. So everything on the left is negative infinity. And since negative infinity goes on forever, you can't capture or include it. It's a parentheses. So I have parentheses. My I stops here at negative 3. But this time it is included. It can be a solution. So if it is a solution, it is a bracket. So this one would be parentheses, negative infinity to negative 3, including negative 3. Okay, I want you to pause the video and try to do 40 and 41 and see if you can write the interval. Okay, so let's see how you did. So with this one, 40, once we solved it, we should have got this. X is greater than negative 3. So it means I put an open circle over negative 3, and this time greater than everything to the right. But remember, when we write the interval, we go from the left to the right. So the leftmost point I see here is negative 3. It's an open circle. It's not included, so it's a parentheses. Everything to the right means it's everything to the right is infinity, positive infinity. So negative parentheses, negative 3 to infinity parentheses, because you cannot capture or enclose infinity. All right, let's take a look at this one. So when you solved it here, remember, we always go from least to greatest. So you had to reorder it and say negative 6 is less than g, which is less than or equal to negative 3. Because again, the number line goes least to greatest. So when we look at the number line, we have open circle above negative 6, closed circle above negative 3. So these are only the numbers in between. We're not going all the way to the negative infinity or to the positive infinity. So our I starts at the left and we go to the right. Open circle above negative 6, so parentheses negative 6, all the way to negative 3. So to negative 3, it's a closed circle, it's included, so it is a bracket. All right, let's go ahead and take a look at the last page of our notes here. Okay, so let's go ahead and try number 42. 42 has an or in it, which means that now I'm going to have to write two intervals. It's going to be this one or this one. So let's go ahead and see what that would look like. So first, I'm going to get x by itself. I'm going to multiply 2 to both sides. So here I'm going to get x is less than or equal to negative 4. Or here, when I add 4 to both sides, I get x is greater than 1. All right, so I'm going to go ahead and draw this on my number line. So I have negative 4 over here. I'll put 0 somewhere here and 1 here. So x is less than or equal to negative 4. So a closed circle above negative 4 and everything to the left. Or x is greater than 1. So open circle above 1 because it's not included and everything to the right, which means I'm going to write two intervals. Your I starts from the left and goes to the right. So the leftmost over here is negative infinity. I can't capture and close infinity, so it's parentheses, comma, to negative 4. My I stops here at negative 4. It's closed circle, it's included, it's equal to, so it is a bracket. And instead of writing the word or, we do this U-shaped sign. It's called union, which means or. And open circle above 1, which means parentheses 1. It's not included. And everything to the right. Everything to the right is positive infinity. So your interval is parentheses negative infinity to -4 bracket, or parentheses 1 to infinity. Okay. I want you to try to do numbers 43, 44, and 45. So pause the video and try those. Okay, so let's see how you did. So for this one, we got -7 is less than W, which is less than -3. So here's what our drawing looks like. And remember our interval. Both of them are not included, so it's parentheses for both of them. All right. The next one, we had an or statement, so we had to write 2 intervals. And on this one, we got r is less than or equal to -6, so it's everything to the left of -6, and r is greater than or equal to 8, so it was everything to the right of 8. So here, when we wrote our interval, remember we start from the left. The left is negative infinity, all the way to here to -6. It's a closed circle, so it's included, so it's a bracket. Then, or our I starts up again at 8, and everything to the right. So it's included, so bracket 8 to infinity. Remember, you cannot capture and close infinity, so it's parentheses. And our last one, you have to rewrite the inequality because it's always from least to greatest. So -1 is less than k, which is less than 3. They're both open circle, so it's parentheses -1, comma 3 parentheses. All right, thanks for watching the video.